Consider the following statements. EU2 plus as F7 configuration. EU2 plus, yes, EU2 plus has F7 configuration and it is a strong reducing agent. Correct. EU2 plus is a strong reducing agent. Why? Because the common oxidation state of lanthanides is +3. If it loses one electron, then EU2 plus is converted to EU3 plus. YB2 plus has F14 configuration. YB2 plus has F14 configuration and it acts as a reductant. Correct. If YB2 plus loses one electron, then it is converted to YB3 plus. Terbium-4 has half-filled f orbital. Terbium-4 half-filled f orbital and is an oxidant. Correct. Why? Terbium-4 gains one electron, then it is converted to terbium-3. So it acts as oxidant. So correct answer is fourth option. Largest internuclear distance. In this, cesium atomic size is large. 1A group elements atomic size. 1A group element atomic size is large. Large size. So 1, 3. 1, 3. Three options are there. NH2 NP6 configuration of anion but not the cation. NH2 NP6 configuration, LIF you can take, dissociate like Li plus F minus. Li plus gain loses one electron. Initially it contains 3 electrons, it loses 1 electron, then total number of 2 electrons is equals to 2. Helium configuration, so it is NH2. F minus, total initially 9 electrons, so if it gains 1 electron, then total number of electrons 10. Element is neon and its electronic configuration is helium 2s2 2p6. Yes, anion configuration is NH2 NP6 but not cation. Q1 isoelectronic cation and anion. K plus Cl minus. K plus Cl minus. Atomic number potassium 19, atomic number chlorine 17. Loses 1 electron, then 18 electrons. Gains 1 electron, then 18 electrons. So no doubt, correct answer is fourth option. 2 unit charge on each cation and anion. Ca2 plus O2 minus. Yes, 2 unit charge on cation and anion. The species with least ionic radius. All these contains 10 electrons. So these are considered as isoelectronic series. Negative charge is directly proportional to size of the ion. Positive charge is inversely proportional to size of the ion. Based on that, fourth option is correct. During the complete combustion of methane, what change in hybridization does the carbon atom undergo? Methane, carbon atom undergoes sp3 hybridization. Carbon dioxide, carbon atom is undergoes sp hybridization. sp3 hybridized carbon is converted to sp hybridized carbon. CH4, this is the CH4 structure. 4 sigma bonds are present, so sp3. CO2 structure, C double bond O, 2 sigma bonds and 2 pi bonds. Pi bonds are not participate in hybridization. Sigma bonds and lone pairs are participate in hybridization. Here 0 lone pairs, 2 plus 0 is equals to 2, sp hybridization. 0.01 mole of H3POX, number of moles of acid is given, 0.01 mole, is completely neutralized by 0.56 grams of KOH. Now calculate number of moles of KOH weight by molecular weight. Number of moles. Potassium 39 atomic weight, oxygen 16, hydrogen 1. So weight is 0.56, molecular weight of KOH is 56. Number of moles 0.01 moles. Acid number of moles, base number of moles remains same. And one more point here you can observe, KOH number of moles are same. In KOH number of replaceable OH groups is equals to 1. Okay. In acid also number of replaceable hydrogen atoms are 1. Then it is completely neutralized. In acid number of replaceable hydrogen atoms are 1. Then the compound is completely neutralized. Based on that, the value of X is equals to 2. If X is equals to 2, that is H3PO2. In H3PO2, number of replaceable hydrogen atoms. How many hydrogen atoms are replaceable? Only one hydrogen atom is replaceable. So X is equals to 2 and given acid is monobasic acid, which has the maximum dipole moment. Angle is 180 degrees, cancel with each other. The angle between chlorines is 180 degrees, cancel with each other. Here, this compound is symmetrical molecule. How? How it is considered as symmetrical? Because chlorine attached carbon, one carbon gap. Again chlorine attached carbon, one carbon gap. Again chlorine attached carbon, one carbon gap. Symmetrical. This is unsymmetrical. Now tell me, for symmetrical molecule mu value is equals to 0. Now here only one chlorine atom is present. Here 3 chlorine atoms are present. If chlorine's angle is 180 degrees, cancel with each other. But here angles are different. So maximum dipole moment is possible in case of second option. Second one is correct. According to valency bond theory, the bonds in methane are formed due to 4 sigma sp3s overlapping. Carbon atom undergoes sp3 hybridization. Surrounding atom hydrogen belongs to s orbital. Between a single bond is present, a single bond is considered a sigma bond. So 4 sigma sp3. Yes. Calculate the oxidation state of cobalt. Cobalt X plus 1 into NCS oxidation state is -1. We know that ammonia is a neutral molecule. Neutral molecule oxidation state is 0. SO3 oxidation state is -2. X is equals to +3. P5. Remove second option, fourth option. Okay. Calculate here X plus ammonia neutral molecule 0, chlorine -1 oxidation state, SO4 -2 oxidation state. X minus 4 is equals to 0, X is equals to +4. Q1. Third option is correct option. 4 into sodium oxidation state 1, X plus 3 into S2O3 -2 oxidation state. 4 plus X minus 6 is equals to 0, X is equals to +2. Cobalt is the neutral compound. 2x plus 8 into 0 is equals to 0, X is equals to 0. 0.1 molar solution of which of the following compound will have the lowest freezing point? Number of solute particles increases, then vapor pressure decreases, freezing point decreases, remaining all are increases, that is RLVP increases, elevation of boiling point increases, depression of freezing point increases, osmotic pressure value is also increases. Now the given compound is dissociated into ions. Here total number of ions 5. 2 plus 2 plus 1, 5 ions. Here total number of ions 3. Here 4. Here 1 cation, 1 anion, 2. Number of ions are increases, then freezing point value decreases. Decreasing order of wavelength is the question. Energy is inversely proportional to wavelength. Now, according to spectrochemical series, energy order NH3 less than En less than Cn minus. NH3, that means 1 less than 3 less than 2. Based on this wavelength order, energy is inversely proportional to wavelength. So 1 greater than 3 greater than 2. The atomicity of nitrogen is X. Nitrogen atomicity. Nitrogen is a diatomic molecule, so atomicity 2. Atomicity of white phosphorus is Y. White phosphorus is available in the form of P4. Atomicity 4. 2 plus 4 is equals to 6. Fourth option. Assertion: helium balloons are used in meteorological studies. Correct. Helium is a lighter gas and non-inflammable. Correct. A is true, R is true, R is the correct explanation of A. Oxoanion that contain all equivalent MO bonds. All equivalent MO bonds. CrO4 2 minus contains all equivalent MO bonds. MnO4 minus contains all equivalent MO bonds. Cr2O7 2 minus does not contains all equivalent MO bonds. Because here two types of MO bonds are present. One bond length is 179 picometers. Another MO bond length is 163 picometers. So 1 and 2 only correct answers. CuSO4 plus HCl H2S gives A, which and further reacts with concentrated HNO3 K4FeCN6. Then gives B. The formula of B and its color is, see, according to this equation, CuSO4 reacts with H2S, then it gives copper sulfide. It is a black color precipitate. Which one further reacts with HNO3, then it gives copper nitrate. Copper nitrate dissociate, then it gives Ca2 plus 2NO3 minus. It contains Cu2 plus ions. The Cu2 plus ions reacts with K4FeCN6. Then it gives Cu2FeCN taken 6 times. It is a chocolate brown color complex. Correct IUPAC name of the compound. First give the numbering. Take the long chain. 1, 2, 3, 4. This CHO group not a part of main chain. So use the term formyl. This CHO group, it is a part of main chain. So use the term oxo. Based on that, now follow the alphabetical order. 3 formyl, 4 oxo, butanoic acid is correct answer. Which of the above statement is correct? This is tartaric acid. COOH, CHOH, CHOH, COOH is tartaric acid. In this, two OH groups are present in same side. This is mesotartaric acid. Meso compounds are optically inactive. Bottom onwards, first carbon OH group is present at left side. So this is considered as L-tartaric acid. Question is, which is incorrect? First statement is correct. These are diastereomers and configurational isomers, stereoisomers. So fourth one is incorrect. According to the definition of enantiomers, what is enantiomers? Which are non-superimposable but mirror images. Mirror images. These two are not mirror images, so these are not enantiomers. G should be minimum pKa value. Then G should be acidic nature inversely proportional to pKa. So minimum pKa value means more acidic, and acidic nature is directly proportional to electron withdrawing group. Here NO2 is strong electron withdrawing group, so G should be NO2. Compound reacts with the bromine in the presence of sunlight. Bromine in the presence of sunlight, either allylic or benzylic substitution takes place. This is benzyl hydrogen. Remove benzyl hydrogen. In that place, substitute bromine atom. Now this is alkyl halide, reacts with aqueous KOH. Nucleophilic substitution takes place and it gives CCH3 OH CH3, which one reacts with concentrated H2SO4. Then it gives alkene. Dehydration process takes place now. Dehydration takes place and it gives alkene. C double bond CH2 single bond CH3. Incorrect regarding C. C decolorized bromine water. Yes, this is correct. Why? Because in C alkene group is present. Alkenes decolorized bromine water. Concentrated reaction, C on reaction separately with HBr and HBr plus H2O2 gives the same product. No, does not give the same product. Second statement is incorrect. So take C, C double bond CH2 CH3 reacts with HBr. Follows Markovnikov's rule. Add hydrogen atom at more number of hydrogen side. Carbon, unsaturated carbon which contains more number of hydrogens. Then CH3, CH3. HBr, H2O2. Follows anti-Markovnikov's rule. Add hydrogen to unsaturated carbon which contains less number of hydrogens. Then it gives CH2Br. Compounds are different. Which of the following orders is correct for heat released on hydrogenation of 1 mole each of these compound? Compound is alkene. What is the relation? Heat of hydrogenation is inversely proportional to stability of alkene. We know that the stability of alkene is directly proportional to hyperconjugation effect. And hyperconjugation, it is directly proportional to number of alpha hydrogens. First mark, Here unsaturation is present. This is alpha carbon. This is alpha carbon. This is alpha carbon. This is alpha carbon. Total number of alpha hydrogens, 10 alpha hydrogens are present. This is alpha carbon. This is also alpha carbon. How many alpha hydrogen atoms are present? Number of alpha hydrogen atoms, 3 alpha hydrogen atoms are present. Unsaturation is present between these two carbons. So this is alpha carbon contains 2 hydrogens. This alpha carbon contains 2 hydrogens. Total 4 alpha hydrogen atoms are present. What we know, stability is directly proportional to number of alpha hydrogens according to hyperconjugation. So first stability order. 1 is more stable, 1 after 3 is stable, 3 after 2 is stable. Heat of hydrogenation, order of heat of hydrogenation. Heat of hydrogenation is inversely proportional to stability. So 2 greater than 3 greater than 1. Third option, correct option. Match the following. Teflon, non-stick cookware. A3, only one option. Pyrene, fire extinguisher. DDT, non-biodegradable insecticide. Freon, ozone layer depletion. Correct order for the rate of dehydration. First of all, in dehydration, reaction intermediate. Reaction intermediate is carbocation. The stability of carbocation is directly proportional to electron donating group. Here methyl group is the electron donating group, methyl group. Here ethyl group is the electron donating group. Here isopropyl group is the electron donating group. Here no electron donating group. That's the reason this is least stable. Third one is least stable because absence of electron donating group. So first one, second one, fourth one contains electron donating group. Stability of carbocation is explained on the basis of electron donating group as well as on the basis of hyperconjugation also. In case of first structure, CH3, 3 alpha hydrogen atoms are present. This is the alpha carbon, CH2, CH3. This is the alpha carbon, 2 alpha hydrogen atoms are present. Benzene ring, which carbon atom is directly attached to benzene ring, that is considered as alpha carbon. Here only 1 alpha hydrogen atom is present. So 1 contains more number of alpha hydrogens, 1 after 2, 2 after 4, finally 3. Assertion. Bromination of phenols occurs easily than that of benzene. Correct. OH group attached to the benzene ring is highly deactivating group. Wrong. Why? Because OH group attached to benzene ring, the OH group is acts as electron donating group. Electron donating groups are ring activators. So A is true, R is false. Consider the structure of given alcohol. This alcohol cannot be prepared from. The given alcohol is 3-degree alcohol. What we know? Formaldehyde reacts with Grignard reagent, then it gives 1-degree alcohol. Acetaldehyde reacts with Grignard reagent, then it gives 2-degree alcohol. Ketone reacts with Grignard reagent. Further hydrolysis gives 3-degree alcohol. RCO or ketone reacts with Grignard reagent. So it gives 3-degree alcohol. Ketone Grignard reagent gives. Ketone Grignard reagent gives. But this is acid chloride. Acid chloride reacts with a Grignard reagent. Then it gives 1-degree alcohol. But given alcohol is 3-degree. Fourth option is wrong option. You can check, already explained in grand test 3. Compound reacts with Br2 FeBr3. Okay. With respect to CH3, CH3 is electron donating group, gives ortho or para product. Para position is already occupied with NO2 group. So substitute bromine atom at ortho position. CH3 Br NO2. Now check it. With respect to CH3 ortho position, NO2 is electron withdrawing group, meta position. Correct. Sn plus HCl, reduction takes place. Nitro group undergoes reduction, then it gives amine. NH2 CH3 Br. Now aniline reacts with NaNO2 plus HCl. Diazotization process name. Diazotization takes place, then it gives N2Cl, N2 plus Cl minus CH3 Br. Now BDC reacts with HBr CuBr. The reaction name is called as Sandmeyer reaction. Sandmeyer reaction, then substitute bromine Br CH3. Second one is correct answer. The basicity order of 1, 2, 3. Okay. Aniline is reacts with acid anhydride. Then it gives acetanilide. NHCOCH3. This is in the form of RCONH2 amide. Now acetanilide reacts with the LiAlH4. Reduction takes place. Carbonyl group undergoes reduction. Carbonyl group undergoes reduction, then it gives NHCH2CH3. So this is aniline amine, 1-degree aromatic amine. This is amine. This is also 2-degree aromatic amine. This is amide. Amines are more basic than amides. This is order of basic nature. Because in case of amide, a electron withdrawing group is present, it reduces the basic nature. So 2 is least basic. 2 is least basic, only one option is there. Okay, how 3 is more basic? Here first structure benzene ring, here also benzene ring is present. Here NH2 can be written as NHH. NH. Okay. Here hydrogen atom is present. Here ethyl group is present. Ethyl group is acts as electron donating group. Electron donating group increases the basic nature. 3 greater than 1 greater than 2. The correct statement about the following disaccharide is, according to NCERT lines, ring A represents pyranose with alpha glycosidic linkage. What is the purpose of using ultraviolet light in TLC? To detect colorless compounds that fluorescence under UV light. Generally, organic compounds are colorless and invisible to the naked eye. If we can pass the ultraviolet light, pass UV light to organic compounds, then the compounds are visible. 10 grams of ammonia reacts with 20 grams of oxygen according to the following reaction. Limiting reagent and mass of NO obtained are. First find out the limiting reagent. Limiting reagent, number of moles calculate. Number of moles, given weight is 10 grams, so molecular weight of ammonia is 17. 10 by 17 value 0.588. Oxygen 20 grams divides with 32, 0.625. If you want limiting reagent, then the number of moles divides with stoichiometric coefficients. Then the value of NH3 is 0.147, value of O2 is 0.125. Less value substance is oxygen. So oxygen is taken as limiting reagent. When we can use limiting reagent concept? In a chemical reaction, more than one reactant is present, then formation of product is depends upon limiting reagent. According to this equation, 5 into 32 grams of oxygen requires 4 into 30 grams of NO. Then for 20 grams of oxygen, how many grams of NO is required? 20 into 4 into 30 by 20 into 4 into 30 by 5 into 32. 5 4 times 4 4 16, 16 2's 32, 15 times, so 15 grams. O2 and 15 grams is correct answer. Molarity is given, calculate the molality. The relation between molality and molarity is, this is the relation. Now substitute 1000 into M 3 by 1000 into D 1.25 minus 3 into molecular weight of the solid, NaCl molecular weight 23 plus 35.5, 58.5. Now simplify, then you will get 2.79. Carey's method for estimation of halogens, 180 milligrams of an organic compound. Weight of organic compound 180 milligrams converted to grams, 180 into 10 power minus 3 grams. Produced 143.5 milligrams, 143.5 milligrams converted to grams, 10 power minus 3 AgCl. The percentage composition of chlorine in the compound is, so into 100 into 35.5 by 143.5. Now you can simplify, you will get 19.72. Arrhenius equation is given. In this equation, e power minus Ea by RT represents fraction of molecules. Fraction of molecules having kinetic energy greater than activation energy. Then if kinetic energy is more than activation energy, then only proper collisions are possible or fruitful collisions are possible. The pH of 10 power minus 3 molar solution of ethylamine. Ethylamine is a base. pH value is given as 9. For base, you can calculate pOH value. 14 minus 9 is equals to 5. And OH minus ion concentration, pOH is equals to 5. Then OH minus ion concentration is 10 power minus 5. Concentration is given. Concentration is equals to 10 power minus 3. We know that OH minus ion concentration is equals to square root of Kb into C. Then Kb is equals to OH minus whole square by C. OH minus is 10 power minus 5 10 power minus 5 whole square by concentration is how much? 10 power minus 3. Simplify, you will get 10 power minus 7. Enthalpy values are given. Standard enthalpy and standard entropy of decomposition of N2O4 to NO2 are 55.0 kilojoule per mole and 175 joule Kelvin inverse. Enthalpy is given in terms of kilojoules, entropy is given in terms of joules. So kilojoules is converted to joules. Calculate Gibbs energy. This is the relation. Now substitute the values. 55,000 minus 298 into 175. 298 into 175 value is 52,150. You will get 2850. Second option correct. The above diagram, the standard electrode potentials are given. The value of E0 FeO4 2 minus by Fe2 plus. Okay, first FeO4 2 minus is converted to Fe3 plus. EMF value 2 volts. Fe3 plus converted to Fe2 plus. EMF value 0.8 volts. Fe2 plus is converted to Fe. The EMF value is minus 0.5. Here no need to consider this step. Why? Here FeO4 2 minus is converted to Fe2 plus. Then calculate EMF for this reaction. Using Gibbs free energy, delta G is equals to minus NFE. Delta G is equals to delta G1 plus delta G2. Substitute the values. N1 value 3. How N1 value is 3? Here calculate the oxidation state of iron in FeO4 2 minus. X minus 8 is equals to minus 2. X is equals to plus 6. Plus 6 plus 3. Difference is 3 electrons. Plus 3 plus 2. Difference is 1 electron. Plus 6 plus 2. Difference is 4 electrons. Substitute the values. Then E is equals to 6.8 by 4. You will get 1.7. A molten solution of aluminum chloride electrolyzed for 30 minutes using a current of 2 amperes. Current is given in terms of amperes, so time is taken in terms of seconds. Calculate the amount of aluminum. Question is calculate the amount of aluminum, not amount of aluminum chloride. So in aluminum chloride, dissociate Al3 plus 3Cl minus. What is the formula according to Faraday's first law? Weight by equivalent weight is equals to IT by 96500. Your aim is to calculate aluminum weight. So calculate the equivalent weight of aluminum. Equivalent weight of aluminum is equals to atomic weight by valency. That is equals to 27 by 3, 9. Equivalent weight 9. Then W is equals to 9 into 2 into 1800 divides with 96500. Simplify, you will get 0.336 grams. The molar solubility of zirconium phosphate with molecular formula Zr3PO4 taken 4 times. Zirconium phosphate is a A3B4 type of compound. Solubility product formula X power X, Y power Y, S power X plus Y. 3 A's are present. It dissociates, then it gives 3 cations and 4 anions. Number of cations 3, number of moles of anions 4. Simplify, Ksp is equals to 6912 S power 7. S is equals to Ksp by 6912 whole power 1 by 7. Ethane combustion reaction is given. graphite combustion reaction is given, hydrogen combustion reaction is given. Calculate standard enthalpy of formation of C2H6. Here C2H6 term is involved. C2H6 is a product, but standard enthalpy of formation. What is standard enthalpy of formation? Standard enthalpy of formation means formation of product from its standard state. From its standard state. Remember, very important. Bromine liquid form is standard state. Iodine solid is standard state. Carbon graphite form is standard. Phosphorus white phosphorus is standard. Sulfur rhombic sulfur is standard. Remember these. No, from its standard state. From its standard state. So, you want C2H6. First equation, reverse the first equation. Then change the sign. In the first equation, 2 moles of CO2 is present, but given only 1 mole of CO2. That's the reason second reaction is multiple with 2. In the first equation, H2O is present 3 moles, but given only 1 mole. So third equation is multiple with 3. Add all the values. CO2 CO2 cancel, H2O H2O cancel. Then 2C plus 3H2, 3 by 2 O2 plus O2 plus O2. Sorry, here 2 moles of O2. So 7 by 2 O2, 7 by 2 O2 is also cancelled. Then it gives C2H6. Add all these values. Then you will get 191. Nearby answer is third option. Statement based question. Lyophilic soles are more stable than lyophobic soles. Correct. Stability of lyophilic sole is primarily due to the solvation of colloidal particles by the solvent. Correct. Statement 1 is correct. Statement 2 is also correct. Fourth option. Equation is given. 3 statements are given. Which of the following statement is correct? Intensity of red color decreases on addition of oxalic acid. On addition of oxalic acid, the oxalic acid reacts with Fe3 plus ions to form a stable FeC2O4 taken 3 times 3 minus. It reacts with Fe3 plus ions. Oxalic acid reacts with Fe3 plus ions. That means Fe3 plus ions concentration is decreases. Fe3 plus ions concentration is decreases means reactants concentration is decreases. Reactants concentration is decreases. According to Le-Chatelier's principle, backward reaction is favors. That means deep red is converted to colorless. So statement 1 is correct. Addition of HgCl2 decreases red color. HgCl2 mainly reacts with SCN minus and forms a stable complex HgSCN 4 times 2 minus. It reacts with SCN. That means here SCN after addition of HgCl2, SCN concentration is decreases. That means reactants concentration is decreases. Again backward reaction favors. So deep red is color converted to colorless. B also correct. Addition of potassium thiocyanate shifts the equilibrium to right side. Addition of potassium thiocyanate now increases the concentration of SCN minus, increases the concentration of SCN minus, reactants concentration is increases according to Le-Chatelier's principle, forward reaction is favors. So fourth option is correct option. Among the following, the incorrect statement for electron in an atom is, fourth one is incorrect. According to Bohr's model, the magnitude of velocity of electrons increases with increase the n value. No. What we know, velocity of nth orbit Vn is equals to V by n. That means velocity of nth orbit is inversely proportional to n. Consider the reaction. This is the reaction. In this reaction mechanism, 3 steps are involved. In that, 2 fast steps, 1 slow step. Slow step is always rate determining step. Rate is directly proportional to concentration of the reactants. Now 2 fast steps are present. This is one fast step, this is another fast step. In the original reaction, H2 and NO are present as a reactants. Now take the first fast step. By using first fast step, calculate the equilibrium constant. PPC by PRC, N2O2 by NO whole square. Or it can be written as concentration of N2O2 is equals to K equilibrium into NO whole square. According to slow step, rate is directly proportional to concentration of N2, O2 and H2. So substitute N2O2 value in equation 1. Then you will get rate is directly proportional to K equilibrium into NO whole square into H2. So order of the reaction 2 plus 1. 2 plus 1 is equals to third order reaction. Fourth option is correct option. Don't consider the third equation. Why? Because in the first equation already H2 is obtained. N2O2 is converted to NO, then rate will be obtained. Identify A, B, C, X, Y, Z in the following reaction. Okay, MnO4 minus is converted to MnO2. I minus is converted to I2. Calculate the n factors. N factor value of manganese is 3. N factor value of iodine is 1. Exchange the n factor values. So, take 3 moles of MnO4 minus plus I minus plus H2O gives rise to I2 plus MnO2 plus OH minus. Remaining equation you can balance by trial and error method. Here 2 iodines are present. So take 2 moles of iodine, 2 moles of I minus. That means you are increasing the constant number of moles of iodine. Once you are increasing the number of moles of iodine, then automatically you can increase the number of moles of MnO4 minus also. Double you can take. Now check it. Remaining equation is balanced or not. So 6 manganese atoms are present. 6 moles of MnO2 you can take. Oxygens and hydrogens. No. Oxygens here, total number of oxygens 24 oxygens. Here 12 oxygens. Oxygens are not balanced. So this is wrong. Okay. No. Do one thing. Trial and error method. Don't calculate n factor. Directly do the trial and error method. First option you can substitute A value taken as 2 moles of MnO4 minus plus 6 moles of I minus plus 4 moles of H2O gives rise to 3I2 plus 2 MnO2 plus 8 OH minus. Check it balanced or not. 2 manganese atoms, 2 manganese atoms, 6 iodines, 3 to 6 iodines, 4 twos 8 hydrogens, 8 hydrogens, oxygens 2 fours 8, 8 plus 4 12, 8 plus 4 12, charge minus 2 minus 6 minus 8. Here also charge is minus 8. First option is correct option. For the reaction Kp value is given, calculate the value of Kc. We know that Kp is equals to Kc RT power delta N. Delta N is equals to Np minus Nr only for gases. Number of moles of gases products 2, number of moles of gases reactants 1, 2 minus 1 is equals to 1. Take R value 0.0821 liter atmosphere mole inverse Kelvin inverse. Why? What are the units of Kc? Kc units is mole per liter whole power delta N. So now substitute the values and calculate, then you will get 0.0199. This is nearly equals to 0.02. Match the following. Leclanche cell. Yes, reaction at anode. D. 1D. Only one option. Second option. Remaining you can check. The vapor pressure of pure benzene at a certain temperature is 0.850 bar. P naught value is given 0.850 bar. And P value is also given 0.845 bar. Weight of solute is given as 0.5 grams. Molecular weight of solute calculate. Weight of solvent is 39 grams. Molecular weight of the solvent is 78 grams. Simplify. 78 into 0.5 39, 39 cancel, then 1 by m2 is equals to 0.005 by 0.850. m2 is equals to 0.850 by 0.005. You will get 170 grams. Thank you.